This is our last lesson for Unit 1. It's problem solving, which means we're going to have to read word problems, real world problems, and try to solve them by reading carefully and slowly. Problem solving in mathematics can be very confusing if you don't have a strategy. Now, in elementary school, your teachers would have given you lots of different ways to solve with word problems. So I've got a list here, and some of them you already know, some of them might help you, some of them maybe you've tried it but you don't like it. So as we kind of go through this lesson today, we'll hit on a bunch of these different ones. Some of you often are used to doing a need to find statement and then what you're given. If that is a strategy you already use, and keep using that. So any of these strategies you already have from using word problems, if you like them, some of you like to get out a highlighter and highlight the important parts, you keep doing that, okay? So the first question we have, example 1. Meredith has a summer job at a fitness club. She earns a $5 bonus for each student membership and has a $7 bonus for each adult membership she sells. So she's selling memberships. First of all, you've got to read it slowly. Read every sentence individually and make sure you understand it. Write a polynomial expression that describes Meredith's total bonus, and this will be a binomial. Okay, so first of all, we have got English words here, and we need to convert them to math. So what we need is a let statement. We're going to start with a let statement, and this one looks like this. Let S represent the number of students and A represent the number of adult members, because we have two different things going on here. Because the student membership is a different number than the adult membership, so we need two different variables here, S and A. So we need to write a polynomial expression. Now we have some letters to use. We have an S to use and we have an A we can use. So for part A, we want to describe her total bonus, part A. Her total bonus is going to equal, let's just put a B here for bonus. You can put a T, doesn't matter. Really what I'm concerned about is what's coming after this here, the part that comes after. This is the expression that comes after it. Her total bonus is equal to, so for each student she sells, she gets $5. So if she sold 3 student memberships, she would get $15. So what's the relationship there? The relationship is so I'm using S for student, so however many student memberships she sells, she gets 5 times that in money. And she also gets, for every adult membership she sells, she gets $7. So that's the expression. That's all we have to do there, is come up with an expression. So again, the B part here at the front isn't really important. The expression that we're looking for is, I can even erase this B here. We know that that's what the question asked us for. It says it has to describe her total bonus. So this is describing her total bonus. Also have here, it'll be a binomial, and this what we have is a binomial here. This polynomial expression is a binomial. It's got 1, 2 pieces to it, and they're separated by a plus sign, so that makes it a binomial. Okay, so that's part A. Part B says identify the variable and the coefficient and explain what they each mean. Well, we kind of already did that with our let statement. So first of all, the 5 and the 7 are the coefficients. Make sure you can spell these words properly. Part of your communication mark on tests and quizzes is communication, and that includes spelling. So those are the coefficients. And the 5, of course, is for the $5, and the 7 is for the $7. And it also says identify the variable. So the variables are S and A, and we already identified them here. Actually, let me erase those arrows, make that a little more clear. We already said what S and A are, so I could maybe just put a part A up here in front of this part of the question here. This is also part A because I already identified my variables here. I don't really need to write them out twice. Okay, so that's all we had to do for part B. Part C, how much will Meredith's bonus be if she sells 12 student memberships and 10 adult memberships? How much will her bonus be? So this is part C. Let's use purple. Part C. How much will her bonus be? Remember the equation we had? We had a B in front of it first. I'll put it back. You don't have to have that B there, but her bonus is equal to 5S plus 7A. So I just put brackets around it. You don't have to have that, but sometimes it helps us to understand, because when we have an equal sign like I just had here, this is actually an equation, not an expression. This is an expression because it's not equal to anything. This is an equation. So the question only asked for an expression, so I only needed this part. That's why I'm just pointing this out to you here. How much will her bonus be? So we know that her bonus is equal to this expression that we had here. She sells 12 student memberships. So now we know what S is. Remember we said S was a variable, and a variable is something that varies or changes. We don't know what S is. That's why I can't add these two together, because they were variables. I don't know what S is, I don't know what A is. Now I do. I know that if she sells 12 student memberships, I'm going to put that in for S, and 10 adult memberships, I'm going to put that in for A. So now we know that her bonus is equal to 5 times, so the student membership she sold was 12, and the adult membership she sold were 10. Notice I have an equal sign below the one above it, and I'm writing everything vertically, one line below the next. So 5 times 12 is 60, and 7 times 10 is 70. So we get 130. When we have a word problem, we have to end with a word sentence. So we're going to write a therefore sentence. So 3 dots mean therefore. Therefore, so we have to answer the question, how much will her bonus be? Her bonus will be $130. So at the very end, we have to put in our units. In this case, it's a $sign, 130. You can put 2 decimals after if you want, doesn't matter because it rounded nicely, so we could leave it at 130. So that's our first word problem. And when we look at the chart with all of the different kinds of strategies in it, we only want to use the ones that help us. So for example, draw a diagram, that's not helpful this time. Select a tool. In this case, the tool would be that we were using polynomial expressions. Use a systematic trial. So that's a strategy if you really don't know what to do and you're just going to do this all the time. Okay, if she sells 3 memberships, it's $15. If she sells 4 memberships, it's $20. You just kind of make up a pattern here and look for a pattern and try to come up with your equation that way. So there's a lot of strategies here that you may or may not use. Example 2, and this is our second and our last example. This one comes from your textbook. A swimming pool manufacturer installs rectangular pools whose length is twice the width plus 5 meters. Okay, so we first need to understand everything. We understand this part where someone makes swimming pools and they install them and they're rectangular. That's important. Their length is twice their width. So if you want to highlight, the word rectangular is important, and also length is twice the width plus 5 is important. So what we have to do for part A is draw a diagram of the pool. So here's my diagram of a pool, and label the width and length with algebraic expressions. So label the width. So I'm going to let W represent the width of the pool. Remember the past example, I said to start with a let statement, so I can't just start throwing letters around like a W or an X without telling the reader, in this case telling me, what it stands for. So W is the width of the pool. Now I can use a W. There's the label, the width. Now what about the length? The length. So I don't want to use another letter here. If I just use L for length, then I'm not taking into account this piece of information here. The length is twice the width plus 5. The length is twice the width plus 5. So over here, the length is twice the width plus 5 looks like this. Length equals 2W plus 5. That is the length of the pool. So I'm not going to actually use this word length or an L. I'm going to use this expression right here. This is the length. 2W plus 5, this is what I'm using for length. This is what I'm using for width. This is what I'm using for length. So that's part A. Draw a diagram of the pool and label. Now part B says the entire outer edge of the pool must be fitted with coping, which is a cap. So I had to look this up. What's coping? I don't have a pool. Which is a cap used to join the wall of the pool and the deck. So I actually got a picture for you here. So that would be a little piece that goes along here, right? It joins the wall of the pool, which is underneath here, right up to the deck. So it connects those parts there. So it's all along here. Find a simplified algebraic expression that describes the total length of coping needed. Total length of coping. So I now know that coping goes here and all the way around. So the coping's going all around the outside. So is that area, perimeter, or volume? I know you're saying it. Say it out loud. It's perimeter, right? So we're looking for the perimeter. We need to find the perimeter of the pool, and then we'll know, we'll have an expression for the coping. So let me get a pen here. Oops. Okay, there we go. Part B. Well, let's put it right here in the middle. Part B. Part B, we're looking for perimeter. So I'm going to start with P equals. So again, the question asked for an expression, not an equation. I do find it's helpful to make it an equation because this piece here reminds me what I'm looking for. I'm looking for perimeter. So even though I don't have to put that P equals, I like to. It makes more sense to me. You don't have to. So what's the perimeter equal to? So we've got a perimeter. These two sides of a rectangle are equal to each other. And these opposite sides are equal to each other. So looking at the diagram, I know that a perimeter is 2 widths plus, now don't write this down yet, but 2 lengths. That's what perimeter is, 2 widths plus 2 lengths. But I decided not to use an L. So I'm not going to use L. What am I going to use instead of L? Instead of L, I'm going to use this expression right here. So I'm going to erase that L, and I'll even put it in a different color to make it clear for you. I'll use the same purple that's in the diagram. My length expression is 2W plus 5. So that's my 2 lengths plus 2 widths, and that's the perimeter of a rectangle, and you know that from, I don't even know what grade, 5, 6, I don't know what grade you start doing that. The question does say, look back up at question B, it says it needs to be simplified. So I'm going to have to clean this up a little bit here. 2W plus, good thing we learned that distributive property, 2 times 2W, the numbers times numbers, that's a 4. And then letters times letters, I only have 1 W. And distribute 2 times 5, and they're both positive, that's simply a 10. Are there any like terms here? Yes, we have like W's. So I have 2 W's, I'm going to add on 4 more W's. That's going to give me 6W plus 10. So that's an expression for the total length of coping. And because it's a word problem, I'm just going to make a sentence here. Therefore, total length of coping needed is, I have units on this one, 6W plus 10 what, right? The last question was about membership bonuses and we had a $sign here, but this one's not dollars. What are the units here? It's up in the question right at the top. We're talking about meters. So this is meters. Meters. That's the total length of coping needed. That's the end of part B. Now part C says how much coping is required if the width of the pool is 6 meters. Now we have a number to sub in. So we have, this is our coping, total length of coping needed, and we know if the width is 6, so I'm just going to substitute a 6 in there. Part C, I'll start with my simplified expression of 6W plus 10. That's the perimeter. That's the coping is the perimeter. So I'm going to substitute. Always substitute using brackets. I'm going to check some of your homework. You don't substitute using brackets, and here's what happens sometimes. So my width is 6. So I've seen people actually write 66 plus 10 because they didn't use brackets. It's 6 times 6. You have to have the brackets, or you can write 6 times 6. So we get 36 plus 10, 46. Therefore, what does that 46 mean? It costs $46 to put coping on the pool. You know, look at what the question asks for, how much coping is required. So that's the sentence you need to write. 46 meters of coping is required. There's your final sentence. For word problems, read the questions slowly. So what I've done throughout this whole unit, this is our last lesson in Unit 1, I haven't assigned you very many word problems at all. That's why your homework questions, when you look at them on the bottom of your handout, you'll see they're from all different pages. That's because every time we did a new concept in this unit, I didn't assign all the word problems so that we could have just a whole section on just practicing with word problems. So try copying the method I did today, or look at the method that's in your textbook, or if you remember from grade 8 the way you like to solve word problems, how you like to set things up, then you can keep doing it that way. Good luck.